Myself, Dr. G. Srinivas. I am working as assistant professor in EC department, BV Raj Institute of Technology, Narsapur. Today I am going to handle with antenna subject. Today I am teaching wire antennas. Coming to wire antennas, we know that they have without any transmitting medium, means without any wire. If you are able to transmit something and receiving something, means there should be antennas. There should be antennas. Antennas is nothing but they can radiate and receive the signal without any wire or something. So first of all, we will design some basic antennas, that can transmit the signal and receive the signal. So the basic antenna we can design with a simple wire, which we have two wire lines in our home now. With the two wire lines also we can design an antenna. That is the simple antenna is dipole antenna. We can see dipole antennas. If you see dipole antenna is nothing but a two-wire line. A two-wire line is flared apart from each other. If you take some two wires and they are flaring apart, then they can work as antennas. How they will be used for the antennas? Simple two wires, how they will propagate the information, how they will transmit the signal, how they can receive the signal, that we will see now. Okay, now here for that this two-way dipole antenna, this is why we call it as a dipole antenna. It is having two poles. This is one pole, this is second pole. So there are two poles. That's why it is called a two dipole antenna. Okay, for this one we have to give a RF input. Normally that antennas we have to give RF input only, because if we give DC input, they cannot radiate. We have to give RF input. When we give RF input, AC signal we have to give. Alternating current, we should give alternating current. When we give alternating current, they can distribute the positive and negative across the wire. See here how they were distributing. They can distribute positive and negative across the wire. Then what happens? Electric field lines will produce from positive to negative. Electric field lines will produce from positive to negative. The same phenomena will happen here also. Minus, minus, minus. So alternating current, that's why it is always positive and negative will interchange with the time. So, okay, then positive to negative electric field lines will produce. And when they reach the flaring part, then what happens? The same positive once again will distribute here, and the same negative will distribute here. Then here electric field lines from positive to negative. Then something, so once again the same thing will repeat. Then the electric field lines will produce from positive to negative. Then this process will repeat further. This whatever the process happening now, that field lines from positive to negative, the same process will repeat further, and they will go outside the region also. They will go outside the region. Here what happened? There are three lines downwards and three lines upward. Three lines upward. Then what happened? The resultant charge on the conductor surface. There are three lines. These three lines are upward. These three lines are downward. So the resultant charge on the conductor surface is 0. In that case, what happens? These waves will detach from the antenna. They will detach from the antenna. And they travel into the air. See here, here the up to this the waves are confined to conductor, but here the waves are enter into the air. Then they will travel as a plane waves. They will travel as a plane waves here. They will travel as a plane waves. Like this, the waves which are generated from the RF input, they will enter into the air and they will propagate in the air. Okay, and if we connect a receiving antenna, same dipole antenna with the same frequency, with the same length, that can receive these signals. Okay, normally for the dipole antenna, the length of antenna should be lambda by 2. Length of antenna should be lambda by 2. So this is basic mechanism of dipole antenna that we can design at our home also. They are very simple in design. If we take some lambda by 2 length, we can propagate the signal and we can receive the signal. So which frequency they can generate, that is decided by f lambda equal to c by f. We have formula that lambda equal to c by f. So from this, f equal to c by lambda. So from the length of dipole antenna, L equal to lambda 2. From this we will get some lambda value. That lambda value, if you substitute here, the respective frequency will be getting. So whatever the frequency you want to generate, depending on that you can choose the length of the dipole antenna. You can transmit and you can receive the waves. Okay. So for this dipole antenna, normally the they are radiating signals in all directions. They are radiating signals in all directions. Except to top and bottom. So these antennas patterns, if we check here, they are radiating in all directions. See here, all the directions it is radiating except to top and bottom. So that's why we use this type of antennas in our routers. Okay. Normally, if we use some other antennas, directional antennas, that antenna should focus in one particular direction toward the user. But if we use this dipole antennas, there is no need to focus in one particular direction. They can radiate in all directions. That's why mainly we use these antennas in our routers. Okay. Okay, with the same dipole antennas, so if you want to improve the gain, means actually what happening now here, dipole antennas, they are radiating in all directions. They are radiating all directions except to top and bottom. So if you take the horizontal plane, they are radiating in all directions. So when the antenna is radiating in all directions, they can radiate up to certain limit only. They can radiate the signal up to certain range only. Okay, now if you want to transmit the signal to longer distances, you have to improve the gain of antenna. So you have to improve the gain of antenna and you have to limit the direction of antenna to one particular radiation of antenna to one particular direction. Then it can transmit the signal to longer distances like this. If you focus in one particular direction, they can radiate in one particular direction with large high gain and they can transmit to longer distances also. Okay, now. So here if you take such type of antennas, they can transmit longer distances because their energy is focusing in one particular direction. They are not focusing in all directions, they are focusing in only one particular direction. So this type of antennas normally called as directional antennas. They are called as directional antennas. And the one which is discussed here, dipole antennas, they are called as omnidirectional antennas. Omnidirectional antennas. Okay. So now we have seen dipole antennas that they can radiate in all directions. They are called omnidirectional antennas. So next we will see directional antennas, because directional antennas also required because we want to increase the signal to longer distances. For that one we need directional antennas. So now we will discuss some directional antennas. Coming to directional antennas. Coming to directional antennas, normally there are two types of directional antennas are there. First one is Yagi-Uda antenna. Second one is helical antenna. So first of all we will see Yagi-Uda antenna. This Yagi-Uda antenna properties, the basic mechanism of this Yagi-Uda antenna is they coming to basics. They can produce high gain in one particular direction. They can produce high gain in one particular direction. So so the directivity of this antennas up to some above 10 dB also they can produce. About 10 dB also they can produce. Okay. Normally this Yagi-Uda antenna, they are having two types of coming to structure of this Yagi-Uda antenna. They are having normally two types of elements. First one is driven element. That is driven element. Next, some parasitic elements. These all are parasitic elements. Parasitic element. This is also parasitic. First of all, what is driven, what is parasitic? We will discuss now. Driven element means which we are giving, for which we are giving source. So for this here the driven element, normally we use a dipole antenna only. Just now we have discussed the dipole antenna that we are placing here. And for this only we are giving the source. So that is called driven element or active element. This is also called as active element. Okay, now for this we are giving the source, and that is active element. What are these parasitic elements? We don't give any input to these parasitic elements. They simply support the radiation. They won't take input and they won't radiate. They simply either support the radiation, they will reflect, and they will support the radiation. So that type of elements are called parasitic elements. Normally here we are having one reflector here. This is backside which we are placing is reflector. These all are called directors. Okay. So now we will see what is the working of this one. What is the working of this Yagi-Uda antenna? So what we discuss, we have only one driven element that we are giving the connecting the source, whatever the dipole antenna we discussed just now, that I have connected here. Then backside of this one we are connected a reflector. Mainly it will reflect the rays, and directors, they will support the radiation. Here for the reflector and the directors, now we don't give any input. They simply support the radiation. Okay. Now we will see how the working will happen. First of all, when we take this dipole antenna, just now we have seen dipole antenna, they are having radiation in all directions. Except top and bottom. Okay, when we place this reflector, what will happen? Whatever the radiation in the backside, that will be stopped by the reflector. This reflector will stop the, this is driven element, dipole antenna only. So when we place the reflector, that will stop the radiation, and they will reflect to the signal. So that's why what happen now, this radiation will move in one particular direction, and whatever the back lobe now, that will be reduced, and some small side lobes will come here. Then what is the purpose of these directors? Okay, when we place these directors, when we place these directors, the beam width of antenna. What is the beam width? Beam width means beam width between two half power points. This is half power beam width, or between two fasteners. Beam width between fasteners. That beam width will be reduced if you use the directors. Then what happen? The beam width will be reduced and they will focus in one particular direction with a longer distance. Some small side lobes. So when we place these directors, beam width will be reduced. When beam width is reduced, they can focus in one particular direction. They can focus in one particular direction with more gain. Okay, now first of all, when we take the driven element only, there is a dipole antenna that will radiate in all directions except the top and bottom. There is a omnidirectional pattern. When we place the reflector, they will reflect the rays, and some of the reflector rays will go forward and they will increase the gain. And when we use these directors now, that will improve, that will reduce the beam width and they will focus in more longer distances. Okay, coming to construction properties. Coming to construction, what is the length we have to take for the Yagi wood antenna? For coming to construction, we have to take dipole antenna length almost 478 by f megahertz. The length of dipole antenna should be 478 by f megahertz. This is the length of dipole antenna that we have to choose. That is driven element. And the reflector should be 492 by f megahertz. This is the reflector dimension. Then the director dimension should be 461 by f megahertz in feet. These are normally dimensions of your driven element and reflector and directors. And the spacing between them should be lambda by 4. Like that, you have to choose the spacing between the elements. Then this is the best construction that we know. This is the best construction that we know. Then it can give the good radiation in forward direction. Okay, coming to advantages. They are easy to design, and cost is less, and they can improve the front to back ratio. So these are the advantages. Coming to disadvantages. For designing low frequencies, longer length is required. Longer length of antenna at low frequency. And the drawback is because of there is narrow beam width, we need to focus. In the transmitting direction. So if focusing is something, if it is disturbed now, then you will not receive any signal. Okay. Coming to applications, mainly you can use it in high frequency communication, that is 3 to 30 megahertz, and very high frequency communication 30 megahertz to 300 megahertz, and ultra high frequency also you can use 300 to 3000 megahertz. Okay, next one is you can use it in TV transmitting and receiving. Okay, this is one type of antenna, that Yagi wood antenna. Next we will see a helical antenna. Okay, understood this one. Coming to next one, helical antennas. Coming to helical antennas, coming to basics of helical antennas, coming to basics, here a simple wire is wound in the shape of helix. A simple wire wound in the shape of helix. Okay. Coming to properties, what is the properties of this helical antenna? Properties of helical antenna, they can produce circular polarization. What is the advantage of circular polarization? Normally, when we use linearly polarized antennas, they will face the Faraday's rotation and they will bend in the propagation. Then they cannot be received by the receiver. When we use the circular polarization, that Faraday's rotation can be avoided. Okay, na? And there is one more properties of this one is broadband antennas. This is broadband characteristics. They are having broadband characteristics. So these are the major advantage of this helical antennas. Okay. Coming to construction property. Construction. Coming to construction of this helical antenna. This is a grounded. Outer pin is grounded. And coming to inner pin of the SMA connector is connected to helical wire. Inner conductor is connected to helical wire. Okay. Here the major things we need to know is, here the spacing between the two turns is S and the diameter of the wire is D. Then from these two we can make a triangle here S, and here the D is there now, so we need to take circumference here. Circumference equal to 2 pi r actually, but here we have diameter, so we can directly take pi d. So this is the two we have. Then from this we can design a triangle here. Then this is the alpha. This is alpha is pitch angle. Alpha is pitch angle. Okay. From this we can, from this triangle we can get one formula, that is tan alpha equal to S by pi d. Okay, this is formula for pitch angle. From this we can get tan inverse S by pi d. Okay, and one complete turn we can, it is taken as L, that L we can write it here. Okay, one complete turn is L. So from the Pythagoras theorem, L equal to under root of S square plus C square, or S square plus pi d whole square. Okay, this is actually construction of your helical antenna. Construction of helical antenna. Here inner conductor is connected to the helical wire, outer conductor is connected to the grounding plane. Okay, now then this is the spacing between two turns. S is spacing between turns, and D is the diameter of the helical. Okay, then we can form a triangle here, S, and this is C, then angle between them is alpha. So from this pitch angle equal to alpha, then tan alpha equal to S by pi d. From this alpha equal to tan inverse S by pi d. Okay, then here what is the use of this alpha? From this how can we conclude? Okay, if alpha equal to 0, if we take alpha equal to 0 means what happen? The spacing S will be 0. Spacing S will be 0, then this helix will turn here only. Then what will happen? It will act like a loop antennas. It will act like a loop antennas. Okay. If alpha equal to some 90, if you take 90 means this S will be, whatever the S is there now, it will be at infinite extent. It will be at infinite extent. So then what happen? It is simply acting like a monopole antenna. See here, when S equal to some infinity, when alpha is 90, if you taking means S should be infinity. S should be infinity. So that there is no turn. So there is simply wire we will take. That simply wire that will act like a monopole antenna. Okay now. So to design a helical antenna, to design helical, your alpha should be always greater than or equal to 0 and less than or equal to 90. That is the major condition to design a helical antenna. Okay. Then this one only can produce the circular polarization. If you take alpha equal to 0, that will act like a loop antenna. If you take alpha equal to 90, it will act like a monopole antenna. So they both cases will not come under helical antenna. Only when angle is between 0 to 90, then that will only comes under helical antenna. Okay. Coming to modes of, here one more point. Here whatever the grounding we are taking, there are some two types of groundings are there. These groundings, normal grounding if you take now, there will be some minor lobes are very high. So then this is normal case. When you take this cupped ground plane, you can reduce the side lobes. And this one is deep conical ground plane. In this case now, your side lobes will be further reduced. Okay na? When you take normal na, there is a more side lobes will be there. When you take coupled one, then side lobes can be reduced, and when you take deep conical ground plane, then your side lobes will be further reduced. Okay, and they will use for the protection of this helical antenna also. So when you take deep conical antenna, they can reduce side lobes, and they will useful for protection of dipole antenna, for protection of helical antennas. Coming to modes of helical antennas. Normally there are two types of modes are there. First one is normal mode. In case of normal mode, your helical antenna diameter is very small compared to lambda. If you compare with lambda, this diameter is very small, then it is acting like a normal mode. In the normal mode, this helical antenna, normally they will produce this broadside pattern. They want to produce end side pattern, they will produce broadside pattern in the normal mode. Second mode is axial mode. For this case, the condition is D should be comparable with lambda. In this case, this antenna will produce axial pattern, end fire pattern. Okay, it can produce radiation in the axis of the helical antenna. Coming to this normal mode, it will produce normal to the axis. But in the axial mode, it will produce in the direction of axis. Okay, na? Normally we use this axial mode for the normal real-time applications, because in this case only they can produce very high gain, and with the circular polarization also they produce it in this case. But coming to normal mode, they cannot produce that much high gain. But they will produce broadside pattern in this case. Okay, so these are the modes of helical antennas. Coming to applications of helical antennas. Mainly we will use it in satellite and space applications. And next we can use it in ionosphere propagation also. propagation. Why we use this in mainly space and satellite? Because they can produce circular polarization. Because of circular polarization. Because of circular polarization. Why? What is the advantage of circular polarization? Just now I told, when we use linearly polarized wave, they will face the Faraday's rotation and they will bend in the propagation. But when we use this circular polarization, even though Faraday's rotation, uh, they their property will not be lost. Okay, now then we can receive the signal. So that's why we use mainly in satellite and space applications this helical antennas only. And in the ionosphere propagation also we use this one, because the ionosphere will cause the Faraday's rotation to the waves. That's why if you use circular polarization, even though after the rotation also there is no loss in the signal. Coming to advantages of this signal, coming to advantages, it is very easy to advantages, very easy to design, easy design, and cost is also less. Okay. Coming to disadvantages, the space is very high, space required is large, so we need more space to design such type of antennas. Okay, so today we discussed this wire antennas. There are mainly two antennas are there, Yagi-Uda antenna and helical antenna. They are used as a directional antennas, and one is the dipole antenna, that is a omnidirectional antennas. Okay, this is our topic today.
Like, share and subscribe. Hit the bell icon for more updates.